Good afternoon, everybody. I am Dr. Annette Feravich here with Healthy Mind, Body, Spirit. And we are here to present my third episode in our series on depression and behavior. And this episode is on antidepressants. And so let's go ahead and get started then. What I want to do today is talk, first of all, just a little bit about what we were talking about last week. All right, so our very first episode, if you remember, defined what is depression. So we looked at a lot of the statistics, right? And we kind of looked at different measures that we have for depression and talked about some of the differences in depression that we see today compared to depression that we used to see maybe 30 or 40 years ago. In the second episode that we had, it was on, we kind of just did a flip in the title here, was on behavior and depression. And in that episode, we talked a lot about giving you some very good strategies on trying to change your depression using behavior. And now we're going to talk about antidepressants today. And in talking about antidepressants, I'm going to give you an idea of, I'll tell you. So for today's agenda, what we're going to focus on is, first of all, how does the brain work? And we're going to look very specifically at what neurons are. And we need to take a look at this in order to understand better what antidepressants do to our brain. We're also going to look at how does our brain reward us? So what are the main reward systems in our brain? And those are neurotransmitters. So what are neurotransmitters and the important neurotransmitters that are part of the reward center of our brain? And then lastly, what we're going to do is we're going to take a look at how do antidepressants work on my brain. That will better help give us an idea of how our behavior may be at least an alternative to antidepressants, if not a better alternative to antidepressants. So that's what we want to look at today. When we were talking last week, what we were referring to the brain as these networks, these really complex, what we call neural networks. And one of the things that we know about these neural networks is we know that these neural networks are changeable. And what that is called is neuroplasticity. Now, don't let me lose you just because I'm using a neurological term or a psychological term. This is really important for all of us to know, because it used to be in psychology, we didn't think that we could change our brains. We didn't think that we could make new neurons. And both of these things we found over time to not be true. We can grow new neurons, although there's lots of research that needs to be done in this area. But also, more importantly, we can change our brain. And what changes our brain? Certainly, they are chemicals, right? They're chemicals in our brain, and there are chemicals in our bloodstream, hormones. The chemicals in our brain are called neurotransmitters. All right, so certainly chemicals can change our brains. But what I'm suggesting is that it's much more natural to create chemicals that are due to behavioral changes. And also, we forego many of the symptoms or the side effects of these synthetic chemicals, medicine, that is made to change our brain, right? So if we can get our bodies to change our brain in more natural ways, and then what the benefit is for us is that it is a change that may be slow. We don't know. It may be a fast change. We're not exactly sure, right? But what we do know about these changes is that whether or not they are fast or slow, that they are changes that work naturally with our bodies. And this is what's important. And this is what here at Healthy Mind, Body, Spirit that I do that's different than most of other therapies and most other psychologists, is that I look for a very natural way to work with your bodies. And although many that you can find many advocates in the healthcare industry that do advocate more natural ways. You don't very often find both of those things combined, psychology, mental health, along with that kind of nutrition. And then also our mental health also has to do with spiritual health as well. And we know as we go along in these series that we're talking about that there is a great component that spiritual health lends itself to relative to physical health. And of course, all of that is interactive with our mental health as well. So if you're interested in some different ways of looking at your health that don't rely on traditional medicine, please check out my website, www.healthymindbodyspirit.net. And also, please also remember to email me if you have any questions or comments or concerns, because I'm trying to answer some of the questions that you have in a kind of Dear Abby kind of format. So you can remain anonymous and I can answer these questions for you live. So on those things that pertain to your mind, a healthy body, and of course a healthy spirit, you can email me at Dr. Feravich, F as in Frank, ERA, V as in Victor, ICH, at healthymindbodyspirit.net. So this picture that I have is demonstrating these kinds of complex neural networks that we have. And if you recall, in last week's presentation, episode number 2 of the series, we talked about these neural networks as being these highways. And some of these highways we can access very quickly, right? That's the whole idea of a highway. But other times we take rural roads, right? We take back roads, and those roads are slower. They're not as developed. And our thinking can be very much the same way. Our thinking has well-developed pathways that we think very often, right? That we use to judge our world. Sometimes we call those like our glasses that we have, right? Our perspectives. Some of us have a perspective that is more conservative. Some of us have a perspective that is more rebellious. Some of us have a perspective that is more nurturing. Some of us have a perspective that is more intellectual or academic, right? Yeah. And we see our world through those glasses. Well, or through those perceptions. Well, those become well-worn neurological highways in our minds, right? They become the way that we think more and more over time. And what we want to do is make sure that those well-worn pathways are healthy, well-worn pathways, that they just simply are not unhealthy ones. But even when they are, what we're doing through behavioral changes and not relying on synthetic medications to change our brain is we start making those pathways that look like those dirt roads, right, in rural areas that we aren't sure if we want to go down. But then as we go down them, we discover new things, right? And we wear those pathways a little bit more and a little bit more. And that's how we change our thinking. That's how we engage our ability for neuroplasticity. And the problem with using synthetic medication instead of using your brain in authentic ways is we don't know how it ends up changing those neural pathways in ways that we can't change them back again. And that's what we want to talk about. So think about your brain as a superhighway, and what we are trying to do through this healthy mind, body, spirit is we are trying to wear those pathways, make those pathways, and wear out those pathways that are the healthiest ways for thinking for us, right? Okay, all right. What I want to do is I just want to take just a quick look over here at what a neuron looks like. Let's just think about the way that our brain works for just a minute, and let's think about these neuronal pathways for just a minute. Okay, so if we can kind of intellectualize these, or if we can make a mental representation of what is going on in our brain, what we know is that we have neurons that are in our brain and that also run down our spinal cord. and then attach themselves to or connect to nerves, organs, muscles. And what they do is they not only get our brain moving, so these neurons don't only get our brain moving, but they also get our bodies moving. But it's not just one directional either. When we get our body moving because our brain is activated, our brain also then needs messages from our body that says, yes, we're on the right track, right? Yes, your thinking is correct, right? We need messages from our body. And also what we find out too is that our body actually can communicate with our spinal cord directly, and our spinal cord can communicate with our body directly, and sometimes we even bypass cognition. Think about when we touch a hot stove, right? If we were to wait for those neurons to travel from our fingertip, right? Sensory neurons to travel from our fingertip up our spinal cord and then to our brain, that would take a long time. And then back down again to say, withdraw that finger, right? That would take a long time, and most of us would end up with third-degree burns on our finger if it took that long. So what ends up happening is that our sensory neurons communicate simply with our spinal cord, and it retracts our muscles. It says, pulls it back, right? An impulse gives us an impulse that is directly related to our spinal cord, but does not need any information from the brain at that moment. It's not that the brain doesn't kick in. The brain certainly kicks in, right? It kicks in with information about things like pain, for example. But more specifically, it reacts in the same way to any kind of imbalance that we have in our system. Remember what we were talking about last week when we were talking about stress, and we were talking about alarm versus resistance versus exhaustion stage, right? Okay, so what we do is we deplete our resources in our exhaustion stage that we got on board in our alarm stage, right, when we pulled back. But eventually what we said was that we are showing that alarm stage indicates an imbalance in our brains. And in that imbalance comes from an area in the brain that's called the hypothalamus. And here you can see where the hypothalamus is located in our brain. And just to tell you, just to kind of give you an idea of the importance of this location, is you can see that it's well protected in the interior of our brain. You can also tell that by being in the interior of our brain, that this is more of a reflexive kind of behavior, that many non-human primates also have this to tell us things like an imbalance in our hot or cold, right? An imbalance in our blood pressure, an imbalance in our sweating. All of those things indicate that we then begin to need to turn on different chemicals in our body. Chemicals in our brain are called neurotransmitters. Chemicals in our bloodstream are called hormones. And chemicals in our immune system are called lymphocytes, for example, right? And we have T cells and B cells and those kinds of things in our immune system. But here we can see that they are all interconnected because they all indicate the same thing, an imbalance in our body. Remember last week when we were talking, it was called the general adaptation syndrome is what it was called, stress, because we all adapt to stress starting all in the same way, right? Some of us have heard we have a natural immunity, right? We've been talking more and more about that with the virus, natural immunity. What that is that is our automatic response that everybody has, a general adaptation is what it is. And it's a general adaptation for our immune system is what they were talking about. So the natural immunity. But we have a general adaptation for our hormones and for our neurotransmitters. And in the brain, where that starts is it starts with the hypothalamus. And so what I want you to begin to think about is what are the things that the antidepressants may be doing that can disrupt the hypothalamus, that may be disrupting indicators that there are imbalances in our bodies. If we take antidepressants, which are synthetic chemicals for our brain, what we end up doing then is very often we end up anesthetizing all of our emotions and becoming sometimes apathetic. So what does this do to the hypothalamus then? It indicates in part, it may indicate to the hypothalamus that there is not an imbalance in our body, and therefore it does not indicate that we need to make things like our reward neurotransmitters. Some of them you're familiar with, serotonin, for example, and maybe some of you are also familiar with norepinephrine. So what we want to think about then is that when we kick in this mechanism of brain chemicals as well as hormones as well as our immune system, right, that the imbalance starts with the hypothalamus getting an indication from the body something's gone wrong. Okay? All right, good. Now what we see here is different types of cells. And the idea with this is that there are many different types of cells in the body, and they look very different from one another. So here you can see we've got red blood cells. Here you have got these epithelial cells, which are skin cells is what they are. They are first defense to viruses, for example. We see that we have both the sperm cell and the ovum cell. Both of these cells look very different. The sperm cell being the smallest cell in our bodies, and interestingly enough, the ovum cell is the largest cell in our body. And this actually lends itself to theories called, for example, parental investment, which also supports evolutionary theories of why women are more nurturing and why men are more what we call agentic, or they are leadership or dominant oriented. The reason why is because they say that women invest more, even from the ovum being the biggest cell in the body. So something you might want to look into if you're interested, parental investment from an evolutionary perspective. Okay, moving on. We see here also bone cells look different, and we see here nerve cells look different. And so we're going to take a closer look at nerve cells because those, of course, are associated with our brain and our spinal cord. So we're going to take a closer look at nerve cells. All right, and so what we have here then is a different diagram of a nerve cell where we can take a closer look at what they look like. All right, so here we see that nerve cells have on one end of them, they have what's called dendrites. And dendrites are the area of the nerve cell that picks up information. You can see there too that what we have is a cell body. And in the cell body, you can see that we have a nucleus. So often people are most familiar with the cell body and the nucleus, and in the nucleus is where it contains all of our DNA information, right? So all of our biological information. So as we move from the cell body, we travel down what's called an axon. And this axon has got a myelin sheath on it, as you can see. And this myelin sheath allows information to travel more quickly down the axon. We can usually see that some of the reasons why individuals end up having problems with dementia and Alzheimer's sometimes has to do with a deterioration of that myelin sheath. At the end of that then, you can see we have axons. And axons are where we end up transmitting information back to the dendrites. And so what we want to do is we want to take a closer look at that axon. And the reason why we want to take a closer look at the axon is because that actually is where the synthetic antidepressants end up working in that axon when they transmit information from one neuron to the next neuron. And so as we take a close-up look, you can see right there is a bulb of an axon there passing information on to a dendrite, okay? And if we move in a little bit closer, that's what that looks like. And what we see there then is a space in between the axon giving information and the dendrite picking up information there. In that space that is called a synapse, that is where chemicals, neurotransmitters, are then released. So there you see the synapse, and there you can see neurotransmitters are released into that synapse. Now, why is this so important that we're going into such detail about these neurotransmitters? Well, one of the reasons is because in that synapse, we have natural chemicals that are released, and it is that synapse that antidepressants are manipulating. So they're manipulating the neurotransmitters that are released there in that synapse. So let's take a closer look at, first of all, neurotransmitters. All right, so what we said is that neurotransmitters are the chemicals that are released in the brain. And these chemicals are released in the brain, remember, when the hypothalamus then indicates there's an imbalance in the brain. So all I want to do here is I want to give you an opportunity to be able to see and read there on the screen the different types of neurotransmitters. Now, as much as individuals like you to think that they know an awful lot about the brain, you can ask most experts on the brain, how much do they feel that we know about the brain? And many experts will say that we maybe know 1% about the brain. And so when individuals are saying that we need to trust the science, sometimes it's as if scientists know everything there is to know, and this simply just is not true. There is so much about the human body and the human brain, our blood, our chemistry, that science simply doesn't know. When you are trusting medicine and putting your hands in traditional medical doctors, we want to have a better understanding of what they actually know and what they don't know. Remember, this is also going to give you a much better idea about your own health, because right now what we want to do is we want to learn how to take control of our own health. Okay, so hopefully that has given you a little bit of time to take a look at the different types of neurotransmitters. And these, of course, are not all of them, but they are some major neurotransmitters. What we want to study, or what we want to take a look at today, is we want to take a look at what are the reward neurotransmitters. So what are the neurotransmitters that reward our brain and then make us feel good about what we're doing, about the decisions that we make, about the relationships that we're in, right? All of these chemicals are reactions in our brains that are giving us a really good idea of how we regulate our bodies. So these neurotransmitters then help us regulate our brain to help regulate our bodies. But it regulates our bodies, not like our heart and our breathing, although there is that as well, right? But no, regulates our bodies as far as approach or avoid. And so we need these neurotransmitters to help us in regulation of approaching things when it's appropriate and also avoiding things when it's appropriate. Now, what does this have to do with anxiety and depression? Well, what it has to do with anxiety and depression is that when we feel anxious, what we end up doing is having an imbalance in our bodies. And what we need then is the appropriate neurotransmitters, like, for example, GABA, G-A-B-A, which helps us to suppress negative ruminating thoughts, right? So theoretically, you can see that if we increase this neurotransmitter, GABA, G-A-B-A, well, this can help us diminish negative ruminating kinds of thoughts. So theoretically, we certainly can see why somebody might want to change the chemistry in our brain in order to get us to feel better. What they are doing is they are manipulating reward centers of the brain. What I'm an advocate of is let your behavior naturally change the chemistry in your brain. And in naturally changing the chemistry in your brain, you will end up then providing a resource for you that is functioning according to the demands of your environment, right? If it demands that I know that my boss is in a good mood, but I'm too anxious to ask him for a raise, then I'm not regulating appropriately, right? Okay. All right. So let's move on. Okay. All right. So which are the neurotransmitters that we want to talk about, the reward centers? And there's 3, although we can probably talk about ways that the others also affect reward systems, which is important to also think about and important to also know. And the reason why that's important to think about and know is because if these chemicals in our brain are interacting, but we are only manipulating one of those, how do we know how they are changing the interaction with other important neurochemicals, which also interact with other hormones, including stress hormones as well? So we know about the manipulation of one of these at a time, and sometimes more than one at a time. But what we don't know very often is interactions. This is all pretty brand new, which is why we know so very little about the effects of some of these chemicals on our body. Okay, so which ones do we want to take a look at as part of the reward centers of our brain? Serotonin, dopamine, and norepinephrine. Okay, so those are the 3 we want to take a look at. All right, so these are the reward centers of our brain. And the very first thing I want you to kind of pay attention to is that you can see here, if you take a look at some of these specifics that go along with these chemicals, and remember, they say the reward centers of the brain, there are structures associated with these that produce serotonin, that help produce serotonin, that help produce norepinephrine, and that help produce dopamine. There are structures. But when we're talking about these, we really are talking about chemicals. And so if we take a look at, for example, serotonin, you can see that serotonin doesn't really say depression on there at all. It does say obsessions and compulsions, and it does also say memory there. Now I'm going to give you some additional information about serotonin, but I just want you to observe some of the things on this chart. Let's move on to epinephrine, norepinephrine there. So you can see norepinephrine has to do with alertness, concentration, and energy, okay? All right, so, but when we have those 2 combined, norepinephrine and serotonin, what we see there then is anxiety, impulse, and irritability. All right, so increases or dysfunction in those areas, increases, decreases, can cause these different kinds of reactions. All right, let's move down there. And the blue circle there that we have is dopamine. And so dopamine, we can see, is actually associated with pleasure, reward, motivation, and drive. And what we see most often is that our antidepressants manipulate first serotonin and then norepinephrine second, and then serotonin and norepinephrine. We don't see much manipulation of dopamine, and there's a good reason why. All right, so what I'm going to do is I'm going to start with dopamine is what I'd like to start with. Now, Antidepressants very often don't manipulate dopamine, although look out and watch out because many of the antidepressants are probably likely going to be manipulating dopamine more often. And this is something that we want to be very wary of. What dopamine is associated with, although we see it's associated with pleasure, the reason why it's associated with pleasure is it is associated with that anticipation that we have. Those butterflies that we have in our stomach. For example, if we anticipate a date that we might be having with somebody new and we are very excited about it, right? So we feel these what we call butterflies in our stomach, or even sometimes we call it chemistry that we might have with another person, right? Now, trust me, there are other hormones that are going on there as well, right? And hormones are part of the chemistry that's in our bloodstream that's also activated in our brain, okay? First of all, the hypothalamus, then the pituitary gland, and then our hormones change in our bloodstream. But when we're talking about our brain right now, we want to talk about the changes in things like motivation. How does dopamine manipulate our motivation? Well, what we have is two different types of dopamine that we can identify, dopamine 2 and dopamine 1. And why did I say them in that order? Well, dopamine 2 comes on board in anticipation of something. So when I have a goal that I'm getting close to, when I have a date, right, that I'm getting close to, when we're a ways away from that goal, we don't feel as much anticipation about it. Think about the goal that you might have for your 4-year degree, right? If you're 4 years away, you're just starting, we probably don't have excitement regarding that degree. As we get closer, we get more and more excited. That's dopamine, or more specifically D2. D1 is activated once we have gotten our goal. And what that D1 does is it helps us enjoy that goal that we have. It helps us savor that moment more. And if you remember in our last episode on depression and behavior, we talked much more specifically about savoring. So we want to be very careful about people who are manipulating our dopamine, because it's going to clearly manipulate our motivation, and then also feelings of accomplishment that we get that then motivate us again for the next type of reward that we're looking for. All right? One of the things about motivation is that when we have a reward today, we are more likely to be motivated to get that again tomorrow, for example, right? So if you showed me love and affection after I cooked you a decent meal, so after I cooked you a good meal, well, then I'm more likely to do that the next day. So if we want to get our partners, for example, to do something, we want to make sure that we are rewarding those behaviors in ways that our partner finds rewarding, for example. Okay, but we can all do this in the brain as well. We can get those feelings of reward in our brain as well. Okay, so that's dopamine. We don't see dopamine manipulated as often as we see serotonin first and then norepinephrine second. All right, so that is dopamine. Next, what I want to talk to you about is serotonin. Serotonin is most often manipulated in our antidepressants. It was the first neurotransmitter that was manipulated when we were giving antidepressants. Okay. So what I want to show you here is I want to show you what happens then in the synapse. All right, this occurs in the synapse. So if you remember, that is that area then where we have got the axon bulb here that then has got neurotransmitters that the bulbs contain that then is released in the synapse. And so that synapse area, that's why that's so important there. Again, that's where the chemicals are released, whatever neurotransmitter that we're talking about or that is necessary for that event. And then it is picked up by dendrites. And you can see there that there are receptor sites there then. And these receptor sites are specifically shaped in order to take specific neurotransmitters. So you can see there's a unique kind of Y shape there, but there are all different kinds of shapes of the receptor sites, and this is where then they accept the neurotransmitter. Now this is important because what is being manipulated then is the neurotransmitters here in the synapse is what's being manipulated. So that's going to be important to remember as we take a look at what those antidepressants do. Okay, all right, now let's move back to talk a little bit about the other two reward centers of our brain. The next one being serotonin. All right, so what do we know about serotonin? Well, we know that we have manipulated serotonin in rats and mice. And what we found is that rats and mice that have low levels of serotonin actually are angry and aggressive, or aggressive. We don't know for sure if they're angry. We haven't asked rats what they feel, right? But we know that they're more aggressive when they have low levels of serotonin. When rats have high levels of serotonin, they end up socially connecting or becoming more social or more interactive. We also know that serotonin is associated with other things like mood, for example, and also regulates sleep. And so we see that although serotonin is a main neurotransmitter that is manipulated in antidepressants, we see that serotonin is associated with many other things. Now, to increase serotonin doesn't necessarily mean that I increase sleep, for example, but it may mean that I regulate my sleep patterns better than I did. And this can contribute to good mood, right? Additionally, if I increase my social connections, this also can increase my good mood. The problem becomes is that we don't know how the manipulation is actually affecting our levels of serotonin. All right, so that's one of the reasons why when you go and you get antidepressants, anti-anxiety pharmaceutical medication, very often they have to adjust your medication in order to suit you. We are all different in our levels of receptors, in our levels of neurotransmitters, the number of neurotransmitters, in how effectively our axons work, for example. All of those things are variables that change and can affect whether or not a universal antidepressant works for you. Okay, we also know that there are, of course, a number of side effects of antidepressants, including depression. Some of the most severe side effects for antidepressants came with Prozac, and we know that individuals who were on Prozac had sometimes, in some cases, neurotic or psychotic breakdowns from inappropriate changes in levels of serotonin, and that caused them to engage in very aggressive and violent behaviors, and sometimes even suicidal behaviors and suicidal ideation. The worst side effects were on Prozac, but yet still individuals can still get Prozac. So even though we know that there can be severe side effects, we don't very often eliminate that prescription from a resource that individuals can ask for from their medical doctor. Okay, so let's take a look at a few other things that we know about serotonin as well. So we know that it regulates things that may be associated with depression, like, for example, our sleep cycles, our willingness to socially connect with other individuals, and also feelings of aggressive behavior. All of those things can obviously affect our mood. Things like obsessive compulsive behavior, which also is associated with rumination, can also affect our mood as well. But once again, we don't know when we're getting an antidepressant which one of those variables that are associated with serotonin are going to be affected. Other things that are important to know about serotonin is that the only way to actually increase serotonin in the brain to work naturally is through our diet. We should know that 10% of serotonin that we use in our body is made in our brain, while 90% of serotonin is made in our guts. So we really have to wonder why the choice for manipulating serotonin is not in our diets, but rather in our neurotransmitters and brain chemistry that can affect a whole host of other regulatory functions in our brain and in our bodies. Okay, so tryptophan is the ingredient in foods such as turkey, that's in dairy, that's in cheese, that increases, and you can look online to see other foods, and there are vegetables, and individuals who are vegans can also find in pumpkin seeds and other things where you can find increases in tryptophan. So again, that will help you increase serotonin. Tryptophan makes the chemical that makes serotonin, and so therefore through our diet is a much better way, which is behaviorally as well, right, is a much better way to increase levels of serotonin in natural ways rather than taking a look at pharmaceuticals. Okay, here what we have is a study that was done, and I'll find the site for you. I didn't have a chance to get this site. But this is a picture of rats actually helping one another out. And so what ends up happening is that rats find helping rewarding. And so if they find it rewarding, the likelihood of engaging in those behaviors is going to increase because we find those behaviors rewarding. When the serotonin levels and other reward centers of the rats' brains were manipulated, what we found out is that the rats were less likely to help one another. And so scientists speculated, why would they be less likely to help one another? And the reason why is because they speculated that due to the antidepressants, what they ended up doing was being unable to distinguish a stressful situation in another rat. Okay, so this actually disrupted their ability to understand and socially connect. So when those feelings of empathy, is what they suggested, were disrupted due to antidepressants, what they did was they found no distressful situation. See, this is where the hypothalamus would indicate there's an imbalance. So in my ability to interpret that somebody else needs help, what that creates actually in me is a stressful situation. In that stressful situation, then, what I do to help find a stressful situation rewarding is I help one another. When rats had their levels of serotonin and reward centers of their brain manipulated, they no longer found events that were distressing and others distressing, and therefore they were no longer inclined to help. So this demonstrates that these antidepressants are creating a dysregulation in our stress response that also includes an empathetic response. Okay. Now, I want to talk about hormones, which are chemicals in the bloodstream that are also being affected by changes in our neurological chemistry. And we want to consider those as well. Those are catecholamines and corticosteroids. Catecholamines are associated with our adrenaline, and our adrenaline are those things that get our heart rate up, our blood pressure up, and get us ready for action. Corticosteroids actually influence things in our body that get our body ready also for action, but actually in a protective kind of way. This activates more things such as our immune response, for example, and our inflammatory responses. These responses, these two main hormonal groups, catecholamines and corticosteroids, are influenced by our third reward center of our brain, which produces norepinephrine. Okay, norepinephrine is our adrenaline, and in fact, when increased, beta endorphins, which are epinephrine and norepinephrine increase what we call beta endorphins, and beta endorphins are those things that kill our pain. So when we have our adrenaline going, for example, when we are in a marathon, and I've talked about this before, what we end up doing is after the first mile or so, we kind of get into a rhythm, and this rhythm helps us actually not think about the pain that we might be in. And what this is a release of endorphins, beta endorphins, and they are released from epinephrine and norepinephrine. Both of these are neurotransmitters, but they are also hormones as well. So we can find them, or they activate our hormones, catecholamine and corticosteroids, that they're associated with. And these are our stress responses. And so when we are manipulating through antidepressants, our norepinephrine, again, so we manipulate more often serotonin, but we also manipulate norepinephrine. When we are manipulating norepinephrine, what are the things that we're changing? Well, we would be affecting things like our heart rate, our blood pressure, but also things like our stress responses. And so, again, remember, we were saying that the rats were not noticing that another rat was in distress and therefore was less likely to be empathetic. Well, if our stress response is being manipulated, this can create anxiety when we don't need anxiety, but it can also create a kind of complacency when we need to be more anxious and stressed and have our stress response actually kick in. All right, so these are the three things, the three neurotransmitters that are part of our reward system. And what they suggest is that when there are deficits or dysfunction in these reward systems, that is likely associated with depression. And those are the things that need manipulating according to antidepressant theory. Now here what I have is a slide that are the classes of antidepressants. And so once again, the assumption regarding the necessity of antidepressants is that there are deficiencies in one or more of these reward systems in the brain. And so what do we do then? What we do is we are often manipulating, like I said, those neurotransmitters in our brain. And so the antidepressants that manipulate those neurotransmitters are SSRIs. SSRIs are selective serotonin reuptake inhibitors, and SNRIs are serotonin norepinephrine reuptake inhibitors. And so what these are doing then is they are preventing reuptake of the neurotransmitter. Okay, so what exactly does this mean? So you can see here that neurotransmitters go from the vesicles into the synapse, and then they go into the receptor sites. But when the event is over, what they do is through a reuptake that we see here, a neurotransmitter reuptake, they kind of vacuum up those leftover neurotransmitters in the synapse. So once I've, for example, reached my goal, I receive the reward in my brain, but I no longer am walking through day 10 still receiving that reward. Well, what happens to those neurotransmitters that were in the synapse? They are kind of vacuumed up through a system that's called reuptake. They are also dissolved as well through a protein which is called monoamine oxidase is what it's called. Okay, monoamine, that is a protein, and what it does again is it dissolves the neurotransmitters in there. Another antidepressant manipulates this ability to dissolve those neurotransmitters that are in the synapse, okay? We see that high levels and low levels or variations of levels of this monoamine oxidase, which is a protein, actually is associated with antisocial behavior. Okay, so that is this is a protein. It's not a neurotransmitter, all right, but it works with our neurotransmitters in order to get rid of the excess amount of neurotransmitters that are in that synapse. Okay, so one way that we can keep more neurotransmitters in that synapse is if we prevent reuptake. If we prevent those vesicles from basically vacuuming up the excess neurotransmitters. We can also manipulate the monoamine oxidase that's in the neurotransmitter, which is the protein. And in manipulating that protein, we don't then dissolve the neurotransmitter that's in the synapses quickly either. Now remember, when we manipulate these single variables, whether or not it is serotonin, norepinephrine, monoamine oxidase, what we are seeing is that we are disrupting other natural functions, and these are the things that our scientists and pharmaceutical engineers do not know everything about. That's why we have to really be prepared to understand what is going on in our brain when we're taking these antidepressants. So these antidepressants like SSRIs and SNRIs prevent the reuptake of either serotonin or norepinephrine, leaving it longer in that synapse. A very unnatural way that the brain does not work. Okay, and again, it's assuming that those single neurotransmitters that are left in the synapse are not disrupting other kinds of parts of our emotional or behavioral regulation, right? Our emotional regulation or self-regulation. Okay, so what are some common SSRIs? So serotonin reuptake inhibitors. What are some common SSRIs? Well, some common SSRIs are Zoloft, Prozac, and Paxil. As far as SNRIs, I didn't recognize many of the popular SNRIs, and so you can go on the internet and find out a few more of those if you want to, but I didn't recognize those as much. What I wanted to tell you, though, about SNRIs is some of the side effects. That because norepinephrine is associated with regulating heart rate and blood pressure and those kinds of things, when we manipulate norepinephrine using SNRIs, what we find out is that individuals very often have greater dysfunction or problems with heart arrhythmia. So the side effects are increased blood pressure to SNRIs and increased heart rate as well. We haven't seen them being used as much because the side effects are really critical when we're talking about changing our heart rhythms and things like increases in AFib and aflutter, for example. The next class of antidepressants are tricyclic antidepressants. They also call those TCAs. And what these do is they block both serotonin and norepinephrine. One of the things our side effects of these is that they also block other receptor areas such as histamine receptor areas and also areas that are associated with pain. Now, this sounds like this might be a good idea. However, histamine, of course, is a natural response to antigens or foreign antigens that are in the air, for example. So there may be some side effects to blocking these other areas. And what we do know is that also blocking these histamine receptors can cause heavy sedation It also can cause hypertension, things like blurred vision, and can also lead to cardiac abnormalities because we are changing the functioning of our norepinephrine. And so these seem to be a little bit more dangerous and often are used only when some of the other more traditional antidepressants are not effective. As we've said, we talked about the monoamine oxidase as changing protein levels in the brain, and changing these protein levels in the brain then also change the rate at which the neurotransmitter dissolves in the synapse. What we find about using these antidepressants that change that protein in the synapse is that this is related also to hypertension, but also related to stroke because it increases what's called tyramine in the brain. And this increase in tyramine increases catecholamines. And remember, catecholamines are related to norepinephrine, which is related to increases in heart rate and blood pressure. Catecholamines are those things that are stress hormones. They're hormones that I described that get our body ready for fight or flight. So many of these antidepressants are increasing our physiology. But that doesn't mean it's actually increasing rewarding brain chemistry. So this goes to show you the lack of knowledge that we have is considerable in the way that these antidepressants affect us. Other things that you should also know about antidepressants is, we talked about this in our last video, is that they don't often work any better than placebos work. There's approximately a 7% to 15% increase in effectiveness in antidepressants over and above a placebo, which isn't a great increase. We also know that we don't see that increase unless, of course, we have some kind of psychotherapy, and more specifically, positive psychotherapy is what we were talking about last week, and gave you some of those behavioral strategies that you might use in order to change your feelings of depression and happiness that we talked about last week. Okay, we also have the last one there, which is called atypical antidepressants. And these atypical antidepressants can include things such as benzodiazepines, or benzos is what these are called. And what these are a class of agents that work in the central nervous system and are used for a variety of medical conditions, including things like depression, but mostly for anxiety. They have a calming effect on the body, and what they do is typically cause heavy sedation. But more importantly, what these benzodiazepines do is they create a dependence on the drug. And this dependence is significant. It is part of our opioid epidemic is what we see. So painkillers and basically tranquilizers is what we're talking about and what we're giving individuals. And so what we find is a high rate of dependency or a high rate of addiction. And again, these benzos are more often given as anti-anxiety pills. Okay, let's take a look at then what we see to be the consequences of antidepressants. Okay, first of all, most of the information that we get from these antidepressants and how effective these drugs are, these pharmaceuticals, are from the pharmaceutical industries. And so one of the things that we need to demand that the pharmaceutical industries are not part of making regulation relative to drugs, and that there are also independent studies that are being done on these pharmaceuticals, including the vaccines as well. How many of the vaccine studies are being done by the drug companies themselves? And this is one of the reasons why we have to be skeptical of some of the findings that they have. Number two, they have higher rates of suicide when individuals use antidepressants. As we've said before, Prozac has got some of the highest rates of depression as a side effect of taking the antidepressant. We also know, in particular, with sleep sedatives, including, and in particular, these benzos. Typically what they do is they shorten our lifespan by about 20 years. We also see that when using antidepressants and anti-anxiety, we see shrinkage of brain tissue. And this is likely associated with things like apathy and decreased activation in emotional centers of our brain due to the antidepressants. And so when we know that we don't have brain activity, and in particular amygdala activity, emotional centers, emotional activity, we are not making new memories. Our emotions affect our ability to make memories considerably. We see that individuals who use more antidepressants are incarcerated more often. They are more likely to be admitted to mental hospitals. They are more likely to have recurrences of depression, and they are also more likely to have cocaine usage. That when we are increasing these neurotransmitters in our synapses, we know that, for example, dopamine works exactly like cocaine on the brain. The receptors are the same, and it works exactly the same as cocaine. And so when we see manipulation of these reward centers of the brain, they are more likely to precede or predict addiction, in particular for cocaine. And then we also see higher rates of obesity as well. And that can be due to a number of things. That can be due to the side effects of antidepressants, as well as this kind of apathetic result that we end up getting in our feelings. Okay, so that's what I have for you for today on antidepressants. Hopefully that wasn't too deep of a topic. I want you to take a look at episodes on YouTube. So look for them on my YouTube channel, Dr. Annette Feravich. So what is depression? Behavior and depression. And now antidepressants you can find on my YouTube channel, edited. And then also we have got my next topic, episode number 4 in the series, loneliness and health. So please join me live. And if you can't join me live, please make sure that you're emailing your questions to me. Remember, you can email them at Dr. Feravich, F as in Frank, E-R-A-V as in Victor, I-C-H, at healthymindbodyspirit.net. And hopefully you can email me some questions that you have that I can answer them on the air, kind of like I said, in a Dr. Abby kind of format. Okay, and you can also see my edited videos. If you don't want to watch the whole thing, you can watch my edited videos on my website, www.healthymindbodyspirit.net. And you can also see other videos like my self-esteem series and my love and sex in the 21st century series as well. Please remember that Healthy Mind, Body, Spirit is all about giving you a really well-rounded perspective and well-rounded resources on your health. That one of those things, keeping your mind healthy or keeping your body healthy but not your mind, or keeping your spirit healthy but not your body, that those things work in unison with one another. And if we are not paying attention to one, we're going to find deficits in the other. So during this time where we really are paying so much closer attention to our health, I would like to encourage you to take a look at my website. I can give you some really great resources for nutrition, for your mind, and for your spirit that can really also improve your depression. So if you need and increase your levels of happiness. So if you need some specific information, please see me about a free consultation, and I can give you some specific information. All right. So thank you for joining me, and remember, join me next week for our topic on loneliness and health in our series on depression and behavior.